Okay, a few warnings before we go on to percentiles. So, the first warning is that we don't want to use this normal model if the distribution isn't normal. So, remember, we've seen lots of other distributions. We've seen things maybe that are really skewed, right? That would be unimodal and skewed right. We've seen things that are bimodal or multimodal. So, if our data looks like that, we're not going to do a normal model probability. Okay. Similarly, if we have data with significant outliers, remember that the standard deviation and the mean are both very sensitive to outliers. So those outliers are going to change the mean, they're going to change the standard deviation, which is also going to change the probabilities. So that probability isn't going to be reliable if there's outliers in our data. Now, the other two reminders here are just good advice generally. So the first is don't round in the middle, wait and round at the end. So keep as many decimal places as you can until you're at the end of your problem. And also, we don't want to worry about minor differences in results. So remember in the previous video, sorry, we could have used -1e99. Maybe somebody else used -1,000. Maybe somebody else used 0. And we calculated our different probabilities, and maybe we got 0.25971. 0.259708 and 0.259704. Okay, these are basically the same answers. We're only off in the fifth decimal place. So this isn't something where we would really worry about how different these results are. Now that we've talked about this, let's talk about percentiles, which is the same process, but now we're doing it in reverse. So a percentile is a number where a certain percentages of scores fall below that number. So for example, the 25th percentile, which we also call the first quartile, so that's Q1, going back to a previous section. It is the number where 25% of the data is below that cutoff value. Okay. One that comes up pretty regularly is talking about the 99th percentile. So the 99th percentile is the score that's basically the top 1% of the data. It's bigger than 99% of the rest of the data. So using that height data from the last page, what height would a woman have to be in that 99th percentile for height? So just to remind us, we had our normal curve, 64 was in the middle, and then we went up plus 1, 2, 3 standard deviations. So we had 67, 70, and 73. And then going down 3 standard deviations on the other side, we had 61, 58, and 55. So when we're asking this question about the 99th percentile, we're saying, what's the number? And I'm drawing it here, but I don't actually know where it goes, right? So it might be here, it might be further this way or further this way. I'm just saying, wherever it is, we're going to have 99% of the area on this side, and it's the top 1% on this side. So that number, that mystery question mark, that's the 99th percentile. And we cannot figure this out without our calculator. So to figure this out with our calculator, we're going to use something called inverse norm. INV norm. And its name tells you what it's doing. It's doing the opposite procedure that we did before for a normal model. So in the other problems, we were given some heights and we were figuring out information about the probability. Here, we're given information about probabilities and we want to figure out a height that goes with it. So we are doing the inverse of that normal calculation. Inverse normal takes 3 pieces of information. 1, 2, 3. So as in the last problem, it takes the mean and it takes the standard deviation, but it also needs the area to the left or the area below. So in this case, if I wanted to figure out the height a woman has to be in the 99th percentile. So remember, 99th percentile, sometimes we also see this notation P sub 99 for the 99th percentile. Remember that another way of talking about that is that it's the top 1%. So I would go to my calculator and I would do inverse normal. The area to the left, that's 99%. So I convert it to a decimal and I say 0.99. The mean is 64 and the standard deviation is 3. So I would put that into my calculator and it would tell me the height to be in that 99th percentile.